Welcome to the AGWA Automated Geospatial Watershed Assessment Tool video series. AGWA was developed by the University of Arizona with the USDA, ARS, Southwest Watershed Research Center, and the US EPA. AGWA is available at www.tucson.ars.ag.gov/AGWA. Funding for these videos was provided by the Department of Defense Environmental Security Technology Certification Program, ESTCP. This is the first video in this series, Introduction to AGWA. The next video shows how to create an AGWA project and add data using the mountain fire tutorial as an example, which is an actual fire that occurred near Palm Springs, California in 2013. Next, we'll demonstrate how to delineate a watershed, and then how to discretize or subdivide a watershed. Video 5 will show how to parameterize the watershed for pre-fire conditions for the mountain fire tutorial. Video 6 will show how to prepare the precipitation data for input to the Kinross 2 hydrologic model for the mountain fire. In video 7, we'll write the model input file and run the model for pre-fire conditions. Next, we'll create the post-fire land cover in video 8 so we can simulate the mountain fire. In video 9, we parameterize the watershed for post-fire conditions using the land cover layer created in video 8. In video 10, we'll write the model input file and run the model for post-fire conditions. Then, in video 11, we'll compare the results from the pre-fire and post-fire scenarios to see the effects of the fire on runoff and erosion. Video 12 is in two parts to show how to obtain the data required to run AGWA, the DEM, soils, land cover, and precipitation data. Video 13 is also in two parts and shows how to prepare these data for use in AGWA. The last video, number 14, presents some of the management tools available in AGWA. AGWA is an automated GIS interface for ArcMap. It parameterizes and runs several hydrologic models. AGWA is an add-in to ArcGIS, and when you install it, an AGWA toolbar is added to ArcMap with drop-down menus that lead you through, step-by-step, the entire modeling process. AGWA is designed for resource managers to investigate the effects of land cover change in management scenarios, such as military maneuvers, which can disturb soils and vegetation, urbanization, which adds impervious surfaces to the watershed, and fire, which changes soil and vegetation cover properties. AGWA provides runoff, peak flow, erosion, infiltration, and other outputs depending on the model, to help identify sensitive and at-risk areas at the site and downstream. AGWA can be applied in ungauged watersheds or gauged watersheds, like the Walnut Gulch Experimental Watershed in Arizona, that contains a series of flumes to measure stream flow and sediment and a dense network of rain gauges. AGWA is best used for relative change assessments unless you have good rainfall runoff observations and are able to calibrate the model for quantitative predictions. AGWA currently has a U.S. Army Certificate of Networthiness, allowing it to be used on Army computers. The data required to run AGWA and its hydrologic models are nationally available. You'll need a digital elevation model, such as a USGS 10-meter or 30-meter DEM, or you can use LiDAR data. Soils data may be obtained from the Natural Resources Conservation Service, NRCS, as StatsGo or SERGO data, or FAO Soils Map of the World if your watershed is outside the U.S. or crosses the U.S. border. Land cover land use data are available as the National Land Cover Database Multi-Resolution Land Characteristics Consortium, or NLCD-MLRC data, or from the USGS Gap Analysis Project, or the GAP data. There are several sources of precipitation data available, including design storms or observed rainfall. AGWA includes several embedded distributed hydrologic models that can address multiple scales. In these models, watersheds are represented as a series of plains and channels. The SWAT model is used for large basins and daily time steps. It's based on hydrologic response units where the upland plain is drained by a channel that flows through the lower plain. SWAT uses curve numbers to predict infiltration and runoff. The Kinneros 2 model is for small to medium-sized basins and uses event-based time steps like a single rainfall event. The upland plain is drained by a channel that divides the two lower plains. Kinneros 2 uses cascading plains and overland flow to predict infiltration and runoff. The REM model is a hill slope model and is the erosion engine for Kinneros 2. The AGWA workflow begins with the DEM that is used to determine flow direction across the watershed. The flow direction map is then used to determine flow accumulation. These layers are used to identify the watershed outlet and delineate the watershed. Next, the watershed is discretized or subdivided into smaller plains. The soils and land cover data are intersected with the discretized watershed to provide parameters specific to each plain. And finally, the climate data are applied and the simulation is performed. After the simulation is complete, the model results are imported back into ArcMap for visualization. This image shows runoff for a small watershed where darker colors and thicker lines indicate greater runoff, peak flow, sediment yield, or infiltration. AGWA provides several outputs depending on the model. For Kinneros 2, outputs include channel and plain infiltration, runoff, sediment yield, peak flow, channel scour, and sediment discharge. SWAT outputs include precipitation, evapotranspiration, percolation, surface runoff, transmission losses, and water and sediment yield. Results are visualized spatially, as shown in the map in the previous slide, or as a hydrograph shown here of total sediment yield before the blue line and after the red line, a disturbance. Remember that unless your model is calibrated, you should look at the relative difference between the scenarios. AGWA also provides a tabular output that can be used to calculate the relative change between scenarios. AGWA is available at www.tucson.ars.ag.gov/AGWA. The website includes the AGWA package with all of the models and lookup tables needed to run AGWA, tutorials and the data needed to run the tutorials, various publications and documents, and an FAQ section. These videos are intended to supplement and support the AGWA tutorials and online documentation. The next video will show how to create an AGWA project and add the data for the mountain fire tutorial.